Okay, we are back with some quick math, right? We are dealing with analytical geometry. This video is going to be directed at our grade 11s. We start term 3 with analytical geometry. What is analytical geometry? It is when we take our shapes and we go and put them inside a Cartesian plane, right? So there's a Cartesian plane and I've drawn a triangle. So I'm dealing with analytical geometry. So this video will just serve as an overview or a reminder of some things that you would need to know as we delve into this chapter. Okay, like the video, subscribe to the channel, drop a comment if there's some things that you didn't understand or want me to re-explain or want me to cover in a video, and share the content with anyone at grade 11 level or even grade 12 level. They'll benefit from the videos as well. Okay, so some of the things that you'll need to know as you get into this chapter one, and a majority of these things that I'll cover in this video are things you should already know. Okay, but let's cover them quickly. The first one being the gradient formula, gradient, right? So I'm going to make it a AB as a subscript there because I'm dealing with line AB. So I'm finding the gradient of AB. Gradient we know is steepness, okay? Gradient of AB. And that formula, we should know that the Y value is always on top. So let's go with Y2 minus Y1 over X2 minus X1. Okay, over here, we know this is our gradient formula, and gradient refers to the steepness of the line. Okay, notice that the y's are always on top, x is always at the bottom, minuses are in the middle, and these go together as a coordinate. Right, so these are things that we know. Make sure we don't make any of those mistakes when we use the gradient formula. Gradient formula, yes, it's the same as our straight lines. It will be true for our functions. It will be true for analytical geometry, because really all that you have here is maybe 3 straight lines that make up that triangle, right? So all of those things are still valid. Okay, something else we'll maybe need to know for our analytical geometry. I'm going to use a capital M. So notice that this is a capital M. This was a small m. The small m was the gradient. Capital M, I'm also going to make a AB maybe as a subscript. But now I'm dealing with midpoint, okay? And the midpoint formula, that's going to be x1. And I'm adding x2. And I'm dividing this with 2. And then y1. And I'm adding y2 over 2. Okay, now notice this formula has a plus in between. This formula had minuses in between. Okay, and what am I finding over here? This is the midpoint between line AB, midpoint of line AB. Okay, notice how I've written this as well. Okay, so I'm saying M of X and semicolon Y, because this is a coordinate, right? So this is my X coordinate and this is my Y coordinate, and this coordinate's name is M. So this is how I've expressed that. Okay, this over here, midpoint formula. Gradient formula, midpoint formula. Another one that you'll need to know is distance formula. So let's say line AB, and this one is going to be x1 minus x2 squared, and there's going to be a plus, and y1 minus y2, and that's also squared. All of this is under my root. Okay, notice this one, there's a plus in between, and there's a minus rather in between or inside the brackets, and there's a plus in between the brackets. Okay, so these are all things that we know, things that we need to remember as we cover our analytical geometry. So gradient, midpoint, distance. Let's see some other things also. Let's maybe just mention this as well. Tan of theta equals m. What is this one? This is maybe something new, but this over here is the angle of inclination. So there's the angle of inclination, right? And in this case, our m over here is the gradient. What is angle of inclination? Okay, so let's just have a look over here. Let's maybe call this line AB. The steepness of this line can be expressed in 2 ways. One, with a gradient, as we've learned, but it can also be expressed by the angle that's created over here. And this angle is our angle of inclination. What's the angle of inclination? The angle that our straight line makes with the positive x-axis. Okay, always from the positive x-axis, anti-clockwise to my line. But we'll discuss that more in another video at some point. Okay, let's see anything else that we need to maybe just know. Let's mention this as well, right? So if you have parallel lines, then you would know that the gradients, let's write that a bit nicer so we know what we're doing. Gradients are going to be equal. So if you have parallel lines, your gradients are equal. Then another thing to note maybe is perpendicular lines. Perpendicular, the lines make a 90 degrees. The gradient of the perpendicular lines, or rather the product of the gradients of the perpendicular lines, equals to -1. So what am I saying? I'm saying m of the first one multiplied by m of the second one is going to equal to -1. Another way we can remember the same thing is the gradient of the perpendicular line is equal to the negative reciprocal of the other line. Okay, so you change the sign and you flip it. So these two things over here saying the same thing. The two gradients, when you multiply them together, you get -1, or the gradient of the perpendicular line is equal to the negative reciprocal. So I think these are maybe all of the things that you would need to know at this level. Okay, our analytical geometry grade 11. Make sure you know everything on this page. I think another video will spend more time going delving deeper into all of these things, but for now this is a summary. Make sure you know everything that is over here. All right, great, let's get into it.